Before we dive into some notes on a new topic, let's go ahead and practice some previous learning because this is just a really important kind of problem that you know how to answer. So it says, write the third degree Taylor polynomial for f of x centered at x equals 2, where f of 2 equals 4, f prime of 2 equals -1, f double prime of 2 is 0, and f triple prime of 2 is 6. So I'll let you in a second pause the video and attempt this problem. But if you don't remember the general term for a Taylor series, it's the nth derivative evaluated at c, x minus c to the n power over n factorial. So use that general term and formulate the Taylor polynomial that they're asking you for. So go ahead and pause the video and work out this problem. Okay, so hopefully you were able to figure this out. So I'm going to either call this P sub 3, P for polynomial, or T sub 3, T for Taylor. It doesn't matter which one you do. 3 because it's the third degree. And our input is an x. So our 0th derivative is 4. X minus c to the 0 power over 0 factorial. Minus 1, x minus 2 to the first power over 1 factorial. The next term has a coefficient of 0, so we don't even need to write that term. And our last term is going to be 6, x minus c to the third power over 3 factorial. So this is a correct way to write the answer. We could simplify it if we wish. That first term would just become 4 minus x minus 2, the quantity x minus 2 plus 6, x minus 2 cubed over 3 factorial. So 6 is equal to 3 factorial. So those could cancel if you wish, but you don't need to. You can go ahead and leave it as is. Okay, so today we're going to start with a new topic called manipulating Maclaurin. So it's where we take a known Maclaurin series, like e to the x, sine x, cosine x, and we manipulate it to get the Maclaurin series for a different function. So we're going to start out by finding the Maclaurin series for cosine 2x. So let's go ahead and find the first 4 non-zero terms. And the general term. Okay, so f of x is equal to cosine of 2x. So we need to get started with our derivatives. So I'll let you figure out how far you need to keep going in order to get the first 4 non-zero terms. And then as you know, after you have your derivatives, we're inputting a 0 because the Maclaurin series is centered at 0. So go ahead and pause the video, find all the necessary derivatives you're going to need to get the first 4 non-zero terms, input a 0 to all of them, and try to do what the instructions say here. Okay, so I wrote out the first 6 derivatives, and I used chain rule. Hopefully you remember to use chain rule also. And then I evaluated those 6 derivatives at 0. Now I wrote down over here the general term for the Maclaurin series. And let's go ahead and find our series for cosine of 2x. So cosine 2x is going to equal 1 x to the 0 over 0 factorial. X to the 0 and 0 factorial just become 1, so I don't need to write those down. Minus 4x squared over 2 factorial. 2 factorial and 2 are the same thing, so you could just write 2 there if you wished. Plus 16x x to the 4th over 4 factorial minus 64x to the 6th over 6 factorial. Okay, so let's go ahead and talk about our general term. Well, these are some powers of 2 here. So as you know, 2 to the 0 power is 1, 2 to the 1st is 2, 2 squared is 4, 2 cubed, 2 to the 4th. Let's go ahead and write down these powers of 2. Might help us when we write our general term. Okay, so let's go ahead and try to write out our general term. So we're going to do a plus, dot, dot, dot. It's alternating just like usual. So -1 to the n power. And then it looks like we have our same factorials in the denominator that we have with cosine. So it looks like there's 2n factorial here. The same thing up here with the powers of x. It looks like those are to the 2n power also. Let's go ahead and investigate this a little further. If this here is our n equals 0 term, that makes sense because 2 to the 0 power is 1, and then we have x to the 0 power over 0 factorial. This is actually the n equals 1 term. Because look, if our power on x is 2n and we were to input n equals 1, then we would get a power of 2 here. So this is the n equals 1 term. So what do we have here? We have 2 to the 2n power also, because 2 squared is going to give us 4. So here in our general term, I believe we're going to have 2 to the 2n power. Oops, wrong color, purple. 2 to the 2n power. Let's keep going and check it out. So let's go here. So this is our n equals 2 term. Let's see if I plug in a 2 over here to the general term, if it works. If I plug a 2 in here, then I do get a power 4. Let's plug a 2 in here. So that would be 2 to the 4th power, and 2 to the 4th power is 16. Good. And so then this is going to be our n equals 3 term. And that works because if we look down here, 2 to the 6th power is 64. So 2 to the 2n power is also going to be 64 when n is equal to 3. Okay, so actually there's a little bit easier way to write this. This is just going to equal -1 to the n. I can combine these two terms into 1 and make it 2x to the 2n over 2n factorial. So what does this guy down here resemble? He looks really similar to the general term for the Maclaurin series for cosine x, except the x has been replaced with 2x. So it appears that when we change the input to our Maclaurin series, you just change the input also on the general term. Does that mean we're just changing the input on each of these terms? Well, let's go ahead and let me erase some of this and give ourselves a little bit more room to work. Okay. So let's see. Would this series for cosine 2x be the same as 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial? Yes, it would. So our Maclaurin series for cosine of 2x is the same as the Maclaurin series for cosine x, except we're just changing our input from x to 2x. And the crazy cat entered the room. So if you hear some weird noises, that's what's happening. Okay, cool. So now knowing that, let's go ahead and take a minute and write out the first 4 non-zero terms and the general term for both e to the x and e to the 5x. So pause the video and go ahead and do that, please. Okay, so e to the x is 1 plus x squared over 2 factorial. 2 factorial is the same as 2, so I'm just going to leave a 2 there, plus x cubed over 3 factorial. And plus x to the n over n factorial. By the way, these are all Maclaurin series. I didn't write that out in the directions here, but the first 4 non-zero terms and the general term for the Maclaurin series. Okay, so to get e to the 5x, instead of going through all that work that we just did with cosine, let's just go here and replace the x's with 5x. So replacing all of the inputs with 5x, that's it. That's all we have to do to find the Maclaurin series for e to the 5x. Okay, let's go ahead and write out the first 4 non-zero terms and the general term of the Maclaurin series for 1 over 1 minus x and 3 over 1 minus x. So this is one that you have memorized. So go ahead and pause the video and see if you can remember this one. This one's just a really easy one. 1 plus x squared plus x cubed, and then so on. Okay, now this guy, let's go ahead and call f of x equal to 3 over 1 minus x, and that's really the same as 3 and then 1 minus x to the negative 1 power. Let's go ahead and take our derivatives. And input is 0. And go ahead and write out your Maclaurin series. So go ahead and pause the video and do that, please. So hopefully you're able to pause the video. So let's go. Okay, so I have written out all my derivatives. Let's go ahead and formulate our Maclaurin series. So 3 and then 3 over 1 minus x is equal to 3 x to the 0 over 0 factorial plus 3 x to the first over 1 factorial plus 6 x squared over 2 factorial plus 18 x cubed over 3 factorial. So before we do our general term, let's go ahead and reduce these. So we have 3 plus 3x plus 2 factorials is just 2. So this reduces to 3x squared. 3 factorial, 2 factorial is equal to 2. 3 factorial is equal to 6. So 18 divided by 6 just leads us to 3. So this guy, each term, compare it up here to our Maclaurin series for 1 over 1 minus x. Each of these terms was multiplied by 3 to get the terms in the new series. So how is this problem different than the previous one? In the previous one where we did the cosine of 2x, our input x was replaced with a new input. In this problem, if you notice, our input was still an x. Our input didn't change. We didn't have a new input. Instead, the whole function was multiplied by 3. So since the whole function was multiplied by 3, each term in the series gets multiplied by 3. So when we go down here to write our general term, we're just going to take that general term and multiply it by 3. We're not changing the input to 3x. Instead, we're just multiplying the general term by 3. Okay, so why don't you just try a couple more using the new, hopefully some new knowledge that we have. So go ahead for me real quick and write down the first four non-zero terms and the general term for sine of x to the 4th, and then also 7 e to the x. Okay, so go ahead and pause the video and write those out, please. So in order to get the sine of x to the 4th, we're going to write out the Maclaurin series for sine x, which is the odd powers of x. So x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. To get the odd powers, we're going to do x to the 2n plus 1 and then 2n plus 1 factorial. Okay, so let's go up here and we're just going to replace all of these terms here where you see an x. We're just going to replace all of those with x to the 4th, including in the general term. So sine of x to the 4th is going to be x to the 4th minus x to the 4th cubed over 3 factorial plus x to the 4th to the 5th power over 5 factorial, and so on. Could you simplify those terms by multiplying the powers? Yes. Is it necessary? No. Would I do it? No. I just want to keep things as simple as possible, and I don't want to spend my extra time rewriting how those look. So I'm going to go here, put x to the 4th, and then the power is 2n plus 1. And then this is 2n plus 1 factorial. Okay, what about 7 e to the x? Well, the Maclaurin series for e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. Okay, so let's go ahead, and we're not changing the input this time. It's not e to the 7x power, it's 7 times e to the x. So we're just going to go down here to our series and multiply each term by 7. So 7 plus 7x plus 7x squared over 2 plus 7x cubed over 3 factorial. All right, hope you had some success with that, and look for an assignment that I post in Canvas also. Okay, take care.